Okay, so we're on page 17. And again, with math, when you see a bunch of letters, they look intimidating, but usually they just stand for something that actually makes sense. SA means surface area. Okay. 2LW just means there's two sides that are rectangles. You just find the area of each rectangle. So two rectangles. This is two different rectangles, and this is two other different rectangles. So any box or rectangular prism is going to have 6 sides. So this one here, same kind of thing. Like this one we figured out had basically like 2 triangles and 3 rectangles. So you have a rectangle here, you have a rectangle here, and this one here, you have 2 that are the same like that. Yeah. So don't be intimidated by the letters. Usually you get a mark for figuring out which formula to use. You don't have to memorize them. They'll be given to you. Okay, you'll have the sheet. And you get a mark just for like punching in all the numbers from the diagram or drawing a diagram, okay, and filling it in. And then a mark for not screwing up the calculator work, which I've done. So I said if it's a test or something like that and you don't have an answer, just do it twice. Right? It doesn't take very long to punch something in the calculator twice. If you get the same answer twice, great, it's probably correct. Okay, you probably didn't make a mistake punching things. Okay, so let's just do a few questions. Calculating surface areas of 3D objects. So, determine the surface area of a cylinder. Okay, so I'm just going to draw. It says it's a soup can. Okay. It has a diameter of 8 centimeters, so from there to there is 8. Usually I'm not interested in the diameter, but I'm going to find the formula first. It's the surface area of a cylinder, so let's go back a page. And the surface area of a cylinder is 2 pi r squared. What does that represent? What's a pi r squared? It's a circle, right? Yeah, so this means there's 2 circles, one on top, one on the bottom. Right? And this is the other part, the body or whatever. Okay, so 2 pi r squared. And pi r h, isn't it? 2 pi r h. Okay. Okay, so there's no diameter in this formula, so you'll expect this with anything that has circles in it. Quite often you have to turn the diameter into a radius. If the diameter is 8, what's the radius? 4. Yeah, half of that. So radius is 4. So that's what I need to use. Radius is 4. Okay. So instead of r there, just put 4. Instead of that r, put 4. And the h they told us, h is 10. So we just put in the numbers we know, and that's what it looks like. And then we just have to be very careful when we punch it in. So 2 times pi times 4 squared. It's up to you. Like, you can punch it all in one step if you want, or some people like to write down each number and then add them together. It doesn't matter. 2 times pi times 4 squared plus 2 times pi times 4 times 10. And I got 351.9. And they were centimeters. What do I have now? Squared, yes, because it's area, not volume. If it was volume, it would be cubed, right? We don't want to know what's inside the can. We want to know how much space there is around it, right? And then, because I don't have an answer key for that, I'm just going to punch in a second time just to make sure I get the same thing. And I do, so I think it's correct. Okay, so again, pretty straightforward, just be very careful. B, determine the total area of metal needed to make the can. Oh, we forgot to sketch the constituent parts. Okay, it's that plus that plus that. Okay. So how much metal do I need to make this can? Do I already have the answer? If I have to make the can, how much metal do I need? Like, yeah, that's it. If you're making the can, the surface area is how much metal you need. Okay. So we need 351.9 square centimeters. Well, it says to the nearest hundredth. Oops. Do you remember what was it, 8.5 or something? 8.6?
8.5.
We got to punch it in again. That's annoying. 2 times pi times 16 plus 2 times pi times 40 was 351.86. There we go. 0.86. Just going to change that there. We need 351.86 square centimeters of metal to make this can. Metal is one of my favorite words because metal music makes me happy. Metal! Okay. Who's saying metal and metal? Was that Anvil? Anvil, yeah. Everybody know that song? Metal on Metal? Great lyrics. Metal on metal, it's what I crave. Nobody? None of you? Nobody knows Anvil? Okay.
Aren't they like a
80s metal band that like, there's a great documentary about them.
It's on Netflix.
Yeah, yeah. If you have Netflix, watch the Anvil documentary. It's fascinating. Okay. Example 3. Finding the surface area of a sphere. All right. And then calculate the amount of plastic needed to create a beach ball with a diameter of 15 inches. Okay, let's go find that formula. 4 pi r squared. Okay. So it's going to be 4 times pi times, okay, the diameter is 15. What's the radius? Half of 15 is 7.5. All right, so 4 times pi times 7.5 squared. $706. They didn't tell us. Last time they put it to 2 decimal places, so we'll do that. 0.86, and it was inches, so we'll just write square inches. And that's how much plastic we need. Of plastic needed to make this beach ball. Totally useless item, beach ball.
They pop fast.
They pop, and all it takes is the slightest breeze and it blows away. I don't know, like, totally useless item, beach ball.
It may be fun for a little while.
Yeah, I guess if you... No.
Plus you can't hit them too hard, else they'll go.
Yeah, I know, yeah. But they like to use them in movies, eh? Like, oh, look, it's a
Yeah,
pool
like,
party, everybody's happy, beach ball. Yeah.
Yeah.
If you got kids, don't get...
You're like, don't want
If you got kids, don't get a beach ball and break and then they cry, you know, like
Like a balloon, I guess.
Yeah, totally. Okay, example 4, or kite.
Yeah.
Finding the surface area of a rectangular prism. Okay, an online company ships its merchandise in insulated boxes that measure 20 inches long, 14 inches wide, and 10 inches high. Calculate the surface area. So you don't have to draw it, though it's kind of fun. And I realize my definition of fun is a little, probably not the same as yours. Okay, this is 20 that way, 14 that way, and 10 that way. Okay, so I could look up the formula and do it that way, or I could just, yeah, do the sides. Surface area is going to be 2 of the 20 by 14s. And it's going to be 2 of the 20 by 10s. And it's going to be 2 of the 10 by 14s. Right? Just looking at it? Okay. If I wanted to write the actual formula, that would be 2 LWs plus 2 LHs.
Yeah.
Plus 2
W.
WHs. But just by looking at it, we can kind of figure it out. All right. Now, because they're all nice numbers, we don't want to use our calculator. What's 2 times 20 times 14? So 20 times 14 is 280 times 2 is 560. 2 times 20 is 40, times 10 is 400. 2 times 10 is 20, times 14 is 280. All right, then you got 560 plus 400, which is 960, plus 280. Well, if it was 1,000 and I added 280, I'd be 1280, and then I take back the 40. So 1240, is that correct? For anybody who wants to use a calculator? I think it's 1240.
It is 1240.
And that would be square inches. It's good to try to do some number crunching in your head once in a while so the brain doesn't go to mush. Right? Good for you? It's like eating vegetables. You all eat vegetables.
Yes.
Okay, good.
Trying to promote healthy food to make it instead of junk.
Yeah. My the way I do it, I try to eat all really healthy foods early in the day, because by the end of the day, I'm just going to eat whatever I want. So, as the day goes on. Any questions? 1240. Okay. Page.
Favorite one is coming up soon.
The what?
Your favorite one is coming up soon.
The cone?
Yep.
My nemesis. Okay. Example 5. Finding the surface area of a 3D object with mixed units. Okay. So this is important to note here. This hasn't happened to us yet. Mixed units means this is in inches, this is in feet.
Oh, okay.
If you're doing any kind of calculations with actual measurements, you have to make sure they're all the same kind of measurement. Okay, you can't have meters and centimeters and inches. That's when we were talking about conversions. We have to convert them. Okay. usually the questions won't be that hard. You're not likely going to have a question where you're converting like kilometers and like inches and those kinds of things. Okay, so this one isn't too bad. If this is 3 inches, let's make a note here. Must have all of the same kind of units before doing calculations. Otherwise you will get the wrong answer, guaranteed. Okay. So if I'm doing something like this, if this is in inches, I'll normally convert everything to the lowest unit, the smallest unit, right? 3 inches, I can convert feet. How many inches are in a foot? 12, yeah, so 5 feet times 12 inches per feet would be 60 inches. So I would use this number in my calculations. 2 feet times 12 inches per foot would be 24 inches. So if I was to calculate the surface area of this box, I would use 3 and 60 and 24. Later on, if I have to, I can convert it back to feet. Or in this case, cubic feet. But I would definitely convert them first. Usually you go down to the smallest unit. I don't have to. I could have gone the other way. So I could have converted 3 inches to feet. How would I do that? Yeah, I would divide. So what it would look like, if I wanted to convert 3 inches to feet, I would have 3 inches times, and I want to have inches on the bottom, so that's where my 12 is. So 1 foot has 12 inches. And that way I can cancel the inches. And what happens is I end up dividing. So 3 divided by 12 would be 0.25 feet. So I could have turned that one into 0.25 and left these as feet. And that would give me a correct answer as well. But do you see, just showing you again the conversion method, if you're careful to always think about, I need to cancel out units, it tells you where to put the numbers, right? 12 inches in 1 foot. I ended up putting it on the bottom because I wanted to get rid of it. Whereas over here, I put it on the top because I wanted to get rid of the 1 foot. Does that make sense? Okay. And it's, you just get better at it. For those of you, are any of you doing science courses or plan to do science courses? Because you have to, usually in the science courses, you have to do lots of conversions, right? And so just keeping your units really nice and neat. In fact, this is probably the only time you'll see me write neatly is when I'm doing conversions. And I'll line them up. Like, okay, this one's got to cancel here, and I just keep moving them until it all works. Okay? Right. Example, it did ask us calculate surface area. Okay, so we'll do it both. So for this one, we got 3 inches. So the surface area would be 2 of the 60 inches times 3 plus 2 of the 60 times oops, I wrote that in the wrong place. It's here. 2 of these 60 times 24s. Okay. And 2 of the 24 times 3s. What's that? Yeah, this is 3 here. Yeah. Yeah, 24 times 3 here. This is doing it all in inches, yeah. 63, 64, yeah. Yeah, this is the inches one. We'll redo it for feet after. Okay, so surface area. again, if you like crunching numbers without a calculator, 2 times 60 is 120, times 3 is 360. This one's a little tougher. 2 times 60 is 120, times 24. I don't know if I'm up to doing that in my head today. Anybody want to take a stab at it? Two times 24 is 48. If I take 48 to 6, and remember I have to add a 0 later, 6. I'm going to cheat and write it down. $268. Yeah. And then I have to put that 0 back, so it's going to be 2,680. And this one is going to be, okay, 3 times 24 is, what, 72? Times 2 is 144? And then if you add it all together, is it 3188 or something like that? All right, 360. What'd you get? 3184. Yeah. I don't know why I said 3188. Okay. And that would be square inches. Okay. And now just to verify how bad my brain is working, I'm going to punch it all in. 2 times 60 times 3 plus 2 times 60 times 24 plus 2 times 24 times 3 equals 3384. So I must have had an error in here somewhere. There, this should have been 8, that's why. There was my error. Which explains why I was out 200. Okay. Okay, and let's just redo this. That's in square inches. And I'm just going to redo this in feet. So this was 5 feet that way. This was 2 feet that way. And we figured out that this is 0.25 here.
We can't see what you wrote.
Oops. 0.25 was this one. So if we're doing this whole thing in square feet, we'd have 2 of the 5 by 0.25s. We'd have 2 of the 5 by 2s. And we'd have 2 of the 2 by 0.25s. I've run out of room, that's why I'm...
Crazy small.
It's crazy small, yeah. 2 times 5 is 10, so this ends up being, I guess, just 2.5. This one ends up being 20. And that one ends up being 1. So 23.5 square feet. Okay. Now the numbers are different, 23.5 and 3,384, because the units are different. But if these are correct, I should be able to convert between the two of them and make sure that they work. I'm going to get a separate piece of paper there just to test it. Because it allows us, again, to use that conversion method. You won't be tested on this, but this is a useful skill, so that's why I'm showing it to you. Okay? I've actually used this. I've had to use this on my own in real life. Okay? It's like one of those math skills. You're like, oh, I actually need this. Okay? All right. So if I have 23.5 square feet, that means feet times feet. That's square feet, right? I want to convert that into inches. How many inches in a foot? 12. So I can write 12 inches over a foot times 12 inches over a foot. Once I've got two FTs on the bottom, I can cancel the 2 on the top. So basically, I just have to take 23.5 and multiply it by 12 twice. And I get this magical number. Where have we seen that before? That number we got when we calculated it all in inches. So I know these two numbers are right now because they match. Okay. Conversely, I could have taken the 3,384. I could have gone inches times inches, and I could have converted that. For each foot, there's 12 inches. For each foot, there's 12 inches. Which means I take this number and I divide by 12 twice. And if I do that, it takes me back to 23.5 square feet. So in practical purposes, you know, if you have a calculator handy, a lot of people have cell phones now. If you ever need to do a quick conversion, you're like, oh, it's feet, inches. You're either multiplying or dividing by 12, and you can do the conversions. If it's square, if you're doing a surface area, you'll do it twice. You're either going to multiply by 12 or divide by 12 twice. If it's volume, you'll be multiplying by 12 or dividing by 12 3 times, and you'll do the conversion. Practical skill. Okay. Example 6. Find the surface area of a cylinder with missing parts. Calculate the amount of cardboard needed to make the paper towel tube shown below. Remember that a paper towel tube has a top or bottom lid. Okay, so with these questions, it's not as simple as just finding the formula because it has missing parts. So if I were to take the formula for a surface area of a cylinder, I would have 2 pi r squared plus 2 pi r h. Okay? What this 2 pi r squared refers to what? The two whats? The two circles, yeah. 2 circles. But this is a tube with open ends, which means I don't have to calculate what's on the end. It's missing. So for this object, this object has no circular ends. It's hollow. And open. What that means is I'm going to go back and just cross that out. So in a question like this, you're going to have to be able to recognize that. If it had an end on it, if one end was open and the other end was closed, what would I do here? I would just cross out the 2 and leave one of the pi r squareds. Okay. So if it has one circle on the end, I would leave one of these pi r squareds. But this one's open on both ends, so I don't do that at all. So the only part I'm doing is, this is the body. Right? Think of this as the top and the bottom, and this is the body. This one has no top and bottom, so I can cancel it out. Okay. So now we're going to go to, so the surface area of the tube, the open-ended tube, is 2 pi RH, which is 2 times pi. In this case, the diameter is 1.7, so r is going to be half that, right? Let's divide that by 2. What's 1.7 divided by 2 without using a calculator? 0.85, yeah. So 0.85, and my height, well, it's turned on its side, which usually we call that a length, but really if you just turned it up, it becomes a height, okay? So that's 11. So 2 times pi times 0.85 times 11. So 58.75 square inches for the tube. Does this idea make sense? Why we cross that off? Yeah. Kind of? So remember, you can always make a page of notes to do tests and stuff. This might be a useful note, right? If I was making notes for myself, I would say something like, oh, watch out for cylinder questions that are missing tops or bottoms. I might need to scratch off a pi r squared for every missing circle. Okay, so you'll see that again. Okay, same idea here. In real life, a lot of cones don't have a top on them. They're open, right? So find the surface area of a cone with missing parts. In this, Regina, or Regina, I guess is a name. That's interesting. Regina is, we call the city Regina, but I've met Reginas. I've never met a Regina. Operates an ice cream shop, and she makes her waffle cones from a special batter. How much batter does she need to make one waffle cone? That's assuming that she's not wrapping it around anywhere. So the surface area of a cone is, we'll go back a page here, pi rs, which is the slant height, plus pi r squared. So pi rs plus pi r squared. Okay, but there's no top on it. Which part of this is the top?
Second one.
Second one, because pi r squared represents a what?
Circle.
A circle. It's got a circular top. So think of this as the body, and this is the top, and this one has no top, so I'm going to cross it off. So I'm just going to go pi times r times s. Well, first of all, r is 3.25 if the diameter is 6.5. Okay, so the surface area of the cone with no, or with an open top, is pi times 3.25 times the slant height, which is this, of 15 centimeters. Okay. I don't mess around with pi calculations in my head, nor should you. 153.15 square centimeters. So again, crossed off the top because it's open. And I might even modify my notes. I might say, watch out for questions where there's some kind of a circular top or a circular end. If it's open, I got to scratch off a pi r squared. Because there's a few shapes, right? There's the cone. There's the cylinder. I could end up with a question in a square-based pyramid where I don't have the bottom if it's turned upside down. I could end up with a triangular prism. Like, I could end up with a tent question or something, you know. Kids are making a tent in the basement out of sheets. There's nothing on the ends. What's the surface area, right? So I'd have to subtract those two triangles there. So there's different ways that can happen in the questions. And you'll get the hang of it. You'll be okay. Just read carefully and know that that might happen with some questions. So we don't have much time left, but you can start working on assignment 4. Probably tomorrow we'll do the first few questions together, but then I'll give you more time to do the problems because I need to give you more time to actually struggle working through the problems. Okay? So tomorrow, you can start now, but tomorrow you'll have some class time as well to finish more problems.